4. Okay, so what we have here, we want 2 through 4 is what we want. What we can do is to get too much, 0 through 4, and subtract out what we don't want, 0 and 1. So that'll be x less or equal to 4, same parameters, so I'll skip them. So then subtract out of that x less or equal to 1. Okay. Wrong page. Alright, we've got that screen up with n of 12, p of 0.1. Alright, so we want 4. Alright, 996. And from 996 we're going to subtract out 0 and 1, which is 659. Alright, that was 996 minus less or equal to 1, which was 0.659. And the answer to that is 0.337. Okay. D was similar, but it was exclusive. So what I intended to mean there was that it excludes the limits. So greater than 2 and less than 4, well actually that's just 3, right? With the same limits. With the same n and p, so I'll skip those. So how do I do that? Well, all I want is 3. So what I'll do is I'll get too much, 0 through 3, and then I'll subtract out 0, 1, and 2. It's a little bit heavy, but that's the way it goes. All I'm doing is subtracting out successive values here. Okay, so let's go to a table. I'm going to get 3, writing these down somewhere else, 974, and then we're going to subtract out less or equal to 2, which is 889. Alright, 974 minus 0.889. Alright, the answer to that is 0.085. Of course, if you were ambitious, you could actually do that calculation with the binomial formula. Let's do that. Alright, so what we have to do is x equal to 3, n of 12, p of 0.1. Alright, to double check. You don't have to do this. I'm doing this because you do need to know how to do it, and this is a good opportunity. So with the formula, that'll be n 12c x, which is 3.1 to the x power times 1 minus, it's p 0.1 to the x power, and then 1 minus p 0.9 to the n minus x, which is to the 9th power. And so 12c3 is 12 factorial. Well, let's stop that. The biggest number on the bottom line is the 9 factorial, so we leave that alone. So on the top we go 12 times 11 times 10 times 9 factorial, so the 9 factorials cancel. 3 goes into 12, 4, and 2 goes into the 4, 2, so we're left with 2 by 11 by 10, which is, by my calculations, just off the top of my head, 220 times the rest, right, 0.1 to the third times 0.9 to the ninth. Let's check that answer. Excel here. So this is equal to 220 times 0.1 to the third power times 0.9 to the ninth power, and hopefully we've done everything right here. And there it is, 0.08523, but that's the same number to 3 decimal places. Okay, so 0.8523. And we're feeling good about ourselves now. Alright, and let's see what else we got. Part E. Oh yeah, more than 8 are not foreign. Okay, there's more than 8 are not foreign. That is, they come from the US, they're paying in US dollars. Where we have 12. Alright, what's the probability that any one customer is not foreign? Well, the probability that they're foreign is 10%. The probability they're not foreign is 0.9. So this is more than 8 not foreign out of 12, where the probability that any one is not foreign is 0.9. Of course, there are other ways you can do this, but that's one way. Alright, the other way you can do it, some of you may have done, is to say that if we got foreigners and say not foreigners, you could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. If you've got 0 foreigners, that means you've got 12 non-foreigners, right? If you've got 1 foreigner, if you've got 11 not foreigners, etc. And the difficult part here is for me to make sure I keep these numbers lined up. Alright, so it says more than 8 are not foreign. More than 8 are not foreign means 9 not foreign or 10 not foreign, etc. And that's identical to 0 through 3 foreigners. Alright, so this is identical to the probability of x less or equal to 3, put the equal sign in now, n of 12, p of 0.1, if we're doing it in terms of foreigners. So this we're doing in terms of not foreigners, this in terms of foreigners. And this number here we can look up directly from our table, so that's the easy way, right? Alright, so n of 12, p of 0.1, and less or equal to 3. Okay, and that's 0.974. Okay, you could have done it the other way, and greater than or equal to 8 would have been equal to the probability that x greater than or equal to 9 out of n of 12, p of 0.9, to make sure you understand, without going through writing it all out. We want the probability of 9, 10, 11, and 12, so what we do is we get the, well, we have it here, we get everything 0 through 12, that's 1, and we subtract out of that 0 through 8. Since we don't want that, we want this part. Alright, so we subtract out x less than or equal to 8, n of 12, p of 0.9. Alright, let's see if we can find that. So p of 0.9 less than or equal to 8. P of 0.9 less than or equal to 8 is here. Okay. And so that's 0 to 6 we're going to take the complement of. And the answer to that is 0.974, which should be no surprise. Okay, so there's more than one way to skin a cat, right? Okay. Alright, and at this point I'm going to stop this